Hi, this video is about an LGP-30 simulator. You may ask yourself, what the heck is an LGP-30? Well, it's a desk-sized computer from the 50s, and it looks like this one. What a beauty! I don't think Johnny Ive could improve this. It may not fit in your pocket, and no, it does not have Face ID, but it can undoubtedly heat your room in the winter and probably burn it down in the summer. Do I own one? No. However, I downloaded a simulator, and that gives me the right to waste your precious time. You have been warned, this video is only for vintage geeks. Several weeks ago I saw this clip. Here's a little teaser for you. You can find the link below and also in the description. I strongly recommend watching the whole thing to familiarize with this desk calculator. I know the video is in German, but you will survive it. You could activate the auto-translation feature. If you understand German, the translation will make you laugh at several positions, and for the other ones, if at some places the reading doesn't make sense at all, you're supposed to smile. On the left at the back you can see the magnetic drum. That's the main memory and also the 3 registers. Below you can see the 113 electronic tubes to drive those 64 read record heads for that memory drum. On the right there is a pluggable logic port with its 680 diodes. This calculator does not have a CPU in a single chip, but the logic is done in 15 flip-flops and 1450 diodes. First watch that video and then come back to this one. Thank you for returning, or were you just too weak or lazy to stop it? I'll give you another chance to leave this forever. 3, 2, 1. Too late. This is a front panel from the video. I will show you the English description. So that's a stop sign, the compute sign. Here's the normal key, the run operation button, the manual input, the standby, the operate, and the standby to operate. That's only a light, an indicator, it's not a button. So here, that's the start button, that's a clear counter, fill instruction, execute instruction, power on, power off, and your breakpoints 32, 16, 8, 4, and that's a 6-put input button, and that's a transfer control. If you want to see the whole warming up process, I will put a video in the description. I will name it a warming up process. So my favorite part is this one, the oscilloscope. So the first row, that's an instruction counter or program counter. This is instruction register and this is the accumulator. At the University of Stuttgart you can find at the Computer Museum section a lot of information about their restored LGP-30. So if you scroll down on their webpage to the bottom, you can find an FTP link to scanned documents, the simulator, and so on. I will put the link to the webpage in the description. The program is called LGP-30 Sim, that's the German version, and EN is the English version. It's an MS-DOS program, so it will only run in a 16-bit environment. If you're running that on a modern Windows, you could enable the anti-VDM, the virtual DOS machine, but I think that only works on a 32-bit Windows system. The easiest way is just to run it in DOSBox or another DOS emulation, for example for Unix. and it works without a problem. Let's launch it. The design of the application is very modest. It's only in text mode, but it works fine. Here is your oscilloscope. That's a counter, instruction register, and the accumulator. Here are your buttons on the front panel. So you have the normal mode, one operation, manual input, and the other ones are the function keys: start, clear counter, fill instruction, execute instruction, your breakpoints, the 6-bit input key, and also the transfer control key. This is the console, and if you want to switch to the flexowriter, you have to type Alt F2. That's the typewriter. You're in the typewriter mode, and that's a guy who has written the program back then. I think it was written in Turbo Pascal. With Alt F1 you switch back to the console, and this is one part of the memory drum. So this is an overview of drum memory. So you have 64 tracks here, from 0 to 63, and it's also divided in sectors. From 0 also to 63, that equals to 4096 words. I will choose another view here. Okay. Here you can see you have your tracks here, from 0 to 63, and at the end you have your recirculating registers. And there are even 64 heads for every track, and in a sector, the sector is divided in 32 spots, you could also say bits, but you can use only 30. The lowest bit is always 0, that's called a spacer, and the most significant bit is it's a sign bit. So if it is a positive number, it's always 0, and if it is a negative number, it's always 1. The registers here, I didn't see it in the English version. I will switch to the German one. Here we have it. You have even 4 synchronization tracks before the other tracks here, and at the end of the drum you have your 3 registers: the accumulator, that's an instruction register, and that's a counter. Back to the other picture. So, for example, in your program you want to read or write to a different track. That's not a performance degradation, because there are 64 read record heads. But if you switch to or want to read from a different sector, there is a difference, because the drum is spinning around and it depends on what sector you are. So if your sector you want to read is behind you, you have to wait a whole turn. So there is an optimum and a non-optimum. So they are not ordered from 0, 1, 2, 3, 4, but there's a specific order. You don't need this because you won't program it, just to explain it. So here in the example, at location 0, so track 0 and sector 0, there's the command B. B means bring, so it does read from a memory and put into the accumulator. So at sector 43, we are at location 0. And the bring command needs 2 to 7 word times. That's the optimum. So here we are at 0 and 43. That's 1, 2, 3. That's okay. It's still in optimum. So that command is okay. And at location 1, there is an A for add, address 51. Add is also 2 to 7. So we are at location 1, 51, that's 1, 2, that's fine, that's optimum. let's have a look at the last command here. Location 2, C means clear. Clear will clear the accumulator, but before I will save it to that address. And 43, so a 2, 43, oh no, that's not an optimal. So it has to wait until the drum has turned around. I think we go back to the simulator. Forget about this. So with the cursor keys you can go one sector up and down. See here, up or down, or even with page up, page down. It goes until 63. Of course you can do this only in the simulator, you can't do that on the real thing. And here we'll go to the next track. And with control you can increment the tracks or decrement the tracks or go to the end. So that's a maximum 63 tracks, 63 sectors. Go one up and we're returning to 0. Okay. For the moment we are in manual input mode. And I want to type something on my flexor writer. So I have to type return here in the simulator. Now we are in input mode, and when I hit something in the flexor writer, I don't have to switch to the flexor writer screen to type something. I can type it right here in the console. So if I type 1, you see 1 bit has arrived in the accumulator. If I hit 1 again, there's another bit. And the first bit moved to the left. I hit another one. See, there are now 3 bits in the accumulator. Or 3, 1. There are even more bits. You see it's 1, 2, 3, 4. 1, 2, 3, 4. It's always 4 bits. Why is that? Because when I go to the flexor writer screen, I've typed only 3 ones. Let's go to the manual. In the LGP-30 input-output mode, you see if you type a 1, and there's a difference. The flexor writer will always send 6 bits. But depending on the key, on the LGP-30, it will read only 4 bits or 6 bits. So the standard is 4 bits. That's why when you hit 1, there are 3 zeros and a 1. But if you are in 6-bit input mode, there will be 3 zeros, 2 ones and a 0. Let's try that. Here I can activate the 6-bit input mode with F9. Hitting F9, 6-bit input mode is activated. Hit 1, and you see here, that's exactly this one. 0, 1, 1, and 3 zeros. So if I hit a 2, that would be 0, 1, 0, 1. 0, 1, I want to hit 2. 0, 1, 0, 1. Let's go back to the flexor writer. You can see it here. The normal mode is 6-bit input mode, so disable the 6-bit input mode again. So what can you actually put in your accumulator? Well, the accumulator can hold any number, any 30-bit number. So on the right side it should be always 0 because you can't change it in the memory due to the spacer. And on the left side the bit is this sign flag. 0 means positive number and 1 means a negative number. The negative number is represented by a complement, or the accumulator can hold an instruction. And the instruction should be in bits 12 to 15, that's the order. and in bit 18 to 23 is the track, and from 24 to 29 is the sector. So, how many instructions are there for the LGP-30? If you look here in the order group, there are 4 bits, so 2 to the power 4, there should be no more than 16 commands. Let's switch back to the picture of a flexowriter, and you can see here there are 16 white keys, and those keys are actually the commands. So for example, the U means unconditional jump, so we'll jump to a specific sector and track. So let me put here a few zeros, type U, 0, 0, 0, 0. So that's the U, jump to 0, 0, 0, 0. So here you can see a U, 1, 0, 1, 0. 1, 0, 1, 0. That's a U. If I go to the flexowriter, I've typed here 3 zeros to clear the accumulator, and the U and 4 zeros. If I hit escape, now I will say fill instructions with F3, and he has put that extraction from the accumulator to the instruction register. And I can't execute instruction here, I have to go to one operation mode, so I type O for one operation mode. Now execute instructions is enabled. I hit F4, and he did jump to 0, 0, 0. Let's go back to manual input mode, hit return, clear the accumulator, unconditional jump to address 0, 1, 0, 0. So it should jump to track 1. Filling instruction, F3, says copy it to the instruction register, but to execute it you have to be in the one operation mode, and execute. And you see here, he has jumped to track 1. So let's go to the flexowriter screen, and you can see here unconditional jump at address 0, 1, 0, 0. So let me do one thing here. If you look at the command here, you have several options here. You can specify a serial console, activate printer, run at low speed, and clear the default ROM. Let me connect a serial port to it. So on the right side I've put a terminal here. Let me launch the program. In my case, serial port 1, 9600 baud, parity none, 8 bits and 1 stop bit. And I won't clear the default ROM, so we will get the same values before we left the program. Terminal is working, and here is our instruction. Okay, manual input mode. Let me put another instruction here. I have to do it here. 0, 0, 0. Unconditional jump, and I want to jump to 800. Hit escape here, and here I have to do F3 for fill instruction, one operation mode, and F4 for execute, and he will jump to track 8. If you want to jump to track address 20, so manual input, unconditional jump, and here you can't specify a 0 because 20 is more than 4 bits can handle. 4 bits, maximum is 15, so you have to type here a 1, that's 16, and 20 minus 16 is 4. So F3 for fill instructions, O for one operation mode, and F4 for instruction execute. So he jumped here to track 20. Another example, this time with a different sector number. So also at track 20, and I want sector 1. So you see here, that's wrong, because the sector begins here, so you have to multiply your sector number by 4. So that's U1404. So that's 1 here. Fill instruction, one-time operations, and execute instructions. So you see here, he jumped to track 20 and sector 1. So one last example. You want to jump at track 63. 63 divided by 16, that's 3 times. 3 times 16 is 48. 63 minus 48 is 15. And 15, that's a W here, because we're only looking 4 bits. That's 1, and 2 is 3, and 4 is 7, and 8 is 15. So you have to choose W. W, and we want to jump to sector 40. 40 times 4 is 160, divided by 16 is 10, and 10 is 8, and 2 is 10. That's F. So we have to type here F0, fill instructions, one-time operation, and execute. So we jump to track 63 at sector 40. So let me write a simple program which will jump from address 0000 to 6340. So we have to change the address 000 F3 and fill it with the jump. You want to jump to 3WF0. One-time operations, execute instructions. So he has put the jump to 6340 at memory location 00. Now at that memory location 3, oh my god, again 3WF0, F3 to put it in the instruction register, and here jumping back to address 00. One-time operation and execute instruction. So now he has put the jump back to 0 at the address 6340. Let's try the program. So we have to clear the counter here with F2 and one operation step, so with F1 he jumped to 6340 and again F1 he jumps back to address 0. If you hit N, normal operations, and start it, the program does not make any sense. As you can see, this is very painful to write code like that, and I can't believe that you're still here. Luckily, there's a more comfortable solution for that. There is an operating system, or you could call it a monitor program, that helps you to enter your code. It is called 10.4 or 10p or +4. Let me clean the terminal window. I'm putting the LGP-30 in manual mode, and I will cheat a little bit. Thanks to the simulator I can load another drum with the 10.4 already loaded. So with Ctrl L, load drum, it's called start, and you can see the operating system is already loaded. I will write the same program using the 10.4 functionalities and with the help of simulated paper tape. How do you simulate a paper tape? Well, that's very easy. Here in the simulator you have the Alt-I function to choose the input method. So Alt-I, you can choose between keyboard, file or paper tape. Paper tape is only used with special hardware. So let me open a text editor to write some paper tape. So the starting address is at 300. In 10.4 the first address you can use for your own program is at address 300, and you specify it here with a semicolon. And close the line with a quote. Then on 300 you do a jump at address 6340. So here with 10.4 you can use your decimal values instead of the 3w.o.p.r. So you use your real address. And at address 6340 you specify a jump back to address 300. And with a dot you're stopping the program. Well, in this case it's an endless loop, doesn't make sense, but I will put it also here. And normally you put the starting address again of the program. Save it, name it nonsense. Back to the simulator, I choose here F for file, nonsense, and start. Yeah, I have to put it in normal mode and start. I hope it has loaded now. So at address 300 there's a jump to 3WF0. And let's check here. At 6340 there's a jump back to 300. Yes, it worked. So I will specify again here the keyboard mode, one operation mode, and clear the counter here with F2, putting it back in normal and starting. And I have to specify the start address with a dot, and it's address 300. So when I start it now, it will run, it will switch between, jump between 300 and 6340 put it in one operation mode. You will see it with F1. Here with F1 you can go step by step. I won't go through every command, every 16 command, because it makes no sense. Nobody will ever watch this. But to terminate the video, I will show two more commands. The Z command means that's a stop. Will stop the program. But you can also specify with the Z command a breakpoint. So let's do it. So before jumping back, I will do here a Z and at address breakpoint 4. Okay. Clear the counter. Reload the program. Nonsense. Normal mode. Start. Let's check it. That's the same. And here you see it's a Z04. And let's check what will happen here. Back to keyboard. Normal mode. And start. Specifying the starting address and hit start. So it has stopped the program because the breakpoint was not enabled. No, when we set a breakpoint to stop the program, here's it's different, it's the opposite. So let's do this again. Start the program again. Reset the counter. Starting address. But before I launch the program, I will set a breakpoint. F7. So, oh no, it was not the 8, I did choose the 4. F8. And I will launch the program. So the program runs. But if I disable the breakpoint now, it will stop the program. You can even mix the breakpoints, for example 32 and 8 and so on. So the last thing I want to show you is how to call a subroutine, because there's no stack pointer. So suppose there's a subroutine at address 400. And at 400 I will do a print. I have to check in the manual. So I want to print OK. So O is 3500. 3500. And you have to wait for the flexor writer. So put the computer on stop. The flexor writer will send a start. And the next character is a K, case 5400. 5400. Again, you have to wait for the flexor writer. And here, normally you would do a return, but there is no stack pointer. So here you can do a jump to anywhere. And before the jump to the subroutine, you have to use the command or and specify here the address. So that's 400, 401, 402, 403, 404. So this command will replace at address 404, that's this one, the destination address. It will replace it with the counter, the counter value +1, so the incremented counter. So here we are at 300, 301, 302. So we will put here 302. And here I want to stop the program. And that's it. Save it. Going back to the simulator. Resetting the counter. Input mode file. Let's reload the nonsense program. Okay. Check it here. That's our or command, u. Oh, was too fast. And here we have our print, wait, and that's jump to 0. Okay, let's launch the program. Back to keyboard, resetting the counter, starting, address 300, and launching the program. See, it has printed out OK and stopped the program. So when we check again here, and here he has replaced 000 with 308. And 308, 8 divided by 4 is 2. So at address 302, there's the stop. I will give you a quick overview of the commands. The bring command here, the add, subtract, you have divide command, multiply. Hold command, clear, extract, store address, return address. You have also seen return address. Unconditional transfer means unconditional jump. When two 30-bit binary words plus are multiplied as a 16-bit product result. You have the test command. Test command is the only conditional jump. It will check if the number is negative. You have a stop command, the print, and also the input command. I want to show you one last thing, and that's the ACT compiler. So let's load this compiler. ACT stands for Algebraic Compiler Translator. This is version number 5. And let's load it. Okay. So we have to load another package. That's basic subroutines. ACT is loaded. Let's have a look at it's just an overview of the commands. It's a high-level language. There are a lot of operators. Oh boy. there's a lot. So here I've written a small hello world program. Let's try to compile it and yeah, run it. Resetting compiler. Going back to keyboard. So the compiler is at address 2000. Now you have to activate breakpoint 8, 4 and 6-bit input mode. Specify your hello ACT program and compile it. So the compilation was successful. Now I can remove the breakpoints and the 6-bit input mode. Going back to keyboard, input mode and resetting the counter, launching the program, and the compiled program is at address 300.